guys, this is Mrs. Gessler, and I'm going to talk about air pressure in this video. I'm going to use some Cornell paper because I really like Cornell paper, and I've got it a little bit pre-filled out, so if you need to pause it so you can catch up while you're writing, that's fine. Make sure you put your name, class period, and date here, and our topic today is air pressure. There we go, now I'm in the video. Okay, so we've got an essential question here, and we're going to be talking about what things affect air pressure and why does air pressure matter. We're also going to talk about how we measure air pressure and what it means. So let's start by talking about what air pressure means. Okay, so air pressure comes because particles bump into each other. So I'm going to write here that tiny particles that make up the atmosphere, make up air, they're always moving. Whoops, there's only one L in always. They're always... and that's one L. They're always moving, and they bump into each other. And everything else. And that bumping applies a force, and that force is where the pressure comes from. So the sum of all the little forces, each individual particle is not very big, but the sum of all the little forces is where we get air pressure. So air pressure is a result of those particles moving around, bump, bump, bump into each other, and that's why we have it. So changes in air pressure, things that change air pressure are things that are going to change the bumping. So I'm going to note that here. What changes the bumping? So if you have more bumping, you have more pressure, and if you have less bumping, you have less pressure. So the first thing we're going to talk about is hopefully a little obvious, and it's the number of particles. Imagine you had a room full of people. They would bump into each other if they were moving around. If you had more people or less people, that would change the amount of bumping. So what we're going to write is that if you have more particles, then you're going to have more bumping. And so the particles change the bumping. So, so particles, increasing particles, increases the pressure. Now, a lot of times when we talk about the number of particles, especially in meteorology class, we're going to talk about density, because if I have this material here with these particles, it has one density, and if I have a more dense, where there's more particles close together, then I end up with a higher pressure. So this is low density, and this is high density. And my high density is my high pressure. So sometimes we talk about density here. In your handy-dandy notebook, there's a picture of particles in the atmosphere that lower down, they're closer together, so it tends to have higher pressure lower down. So the altitude is often where the pressure changes there too. So temperature is another thing that affects pressure. And that's because temperature makes the particle move faster. Temperature determines the speed of the particles. And so if we add heat and we make them warmer, then we end up warmer particles. That means that we have more bumping. So warmer means they're faster. So they're moving faster and they're bumping into each other more. So that's how the temperature affects the pressure. So if you think about the layers of the atmosphere and where the temperature increases and decreases, you have two things going on though when you move through the atmosphere, because the density is also changing. So sometimes these things change at the same time. So for some reason I'm going to flip over to the back of the paper, even though I have a little bit of room here, and we're going to talk about how we measure pressure. And the instrument that we use to measure pressure is called a barometer. And I might draw a picture, but I'm just not going to do very good as the one in your picture or in your notebook, so if you can look there. But the barometer measures pressure relative to something else. So it measures relative to something else. And people have decided that the way the barometer works, and you make one in class, is that we've got some liquid in a tube with a sealed area on one end, and then the other end is exposed to the atmosphere, and when there's more atmospheric pressure, it pushes the water up the tube, and when there's less atmospheric pressure, it pulls the water down the tube, and so we can measure how much it's being moved in that way. So the units that we use to measure is either millibars, which we see often, and that is millibars is about, on average, 1013 millibars is the average kind of air pressure that we have. And then another one that we have is inches of mercury, because one of the liquids that they put in that tube is mercury. Mercury, remember, is that silvery liquid metal. Inches of mercury is another way that they measure it. And so on average, it's about 29.92 inches of mercury. When they give the weather on the news, they often give it in inches of mercury, but when we look at weather maps, it's often in millibars. So that's how that works there. Because of air pressure, though, we have to kind of measure relative to sea level. So remember, the elevation can change the pressure. So it might be useful to note that it's measured relative to sea level. And to help you think about that, Columbia is at about 758 feet above sea level. So that makes our pressure just a little bit lower than say at the coast where they are at sea level. Okay. One more thing, or a couple more things. Why do we care about air pressure? The air pressure changes all the time. It changes all the time, and it turns out that much of our weather patterns are due to changes in air pressure. Pressure changes influence weather. And since it's always changing all the time, then we always have the weather changing all the time, and so it's useful to talk about high pressure and low pressure. So now we've noticed, and you'll notice over time, that high pressure is associated with particular kinds of weather. Often it's better weather. Maybe it's clear, maybe it's not, but it's usually dry. So high pressure is what most people want to have. Sometimes it means that you might have some frost or things taking place, but that's okay at night. Low pressure is often associated with wet weather or storms. Storms are often associated with low pressures, especially when it's really when those pressures are moving that you have things going on, but that's how it works there. Okay, so there's the summary here and some question places that you can write. It's very useful to write those things, so if you do that, that would be awesome. But that's it for this video. Thanks for watching.